whether it's audible. So next important subject with respect to uh, is the role of control and optimization methods in human machine interface. Okay, so you see any measurements, I think everybody would have spoken. All this that is all these measurements with respect to body or artifact, any system with respect to geographical change is done through a sensor. Okay, see, any sensor has a sensor and a transducer is going to exhibit some static and dynamic characteristics, and you see that the inference is any change. Okay, when you see any change, first and foremost is the capture. Any maybe analog circuit or digital circuit. The first and foremost would be a what would be the first and foremost measurement when you get from a sensor? Yes. So any measurement has a problem. So only you see that, sir, see before taking my session, I have to check my mic. Why? Because whether the audibility should reach. Okay, so sometimes if you are not having proper soundproof, definitely it will not reach. Okay, so something has to reach, and whatever the data you are going to get is with noise. Okay, first and foremost, you will get a data with noise. So when you get a data with noise, how we are going to tackle this data for real-time application? So the best example is movement of artifacts. See, suddenly you see a patient subjected with seizure. Seizure means fits. So when you capture the EEG, you cannot take the original signal out of it unless the seizure comes to set. Okay, so when such is the noise, and I have to take the noise, I have to do some filtering. See, low pass, band pass, all these filtering methods are already available. Okay, but so my process itself is has to be defined. Then modeling comes into picture. When there is a model, I have to be very clear whether it is a stochastic system or a random system. So there are many inherent system characteristics are exhibited. So if it's a linear system, no issue. See, if it's a linear system, the complexity is very less. If it's a non-linear system, the complexity becomes very tough. So when we have such measurements, so the criticality in handling the signal, especially before human machine interface, is very, very critical task. So how I am going to handle such task? So there is a problem with noise. I don't know what is the original signal. There is a problem with the measurement. Okay, I don't know the originality. Whether the accuracy is met, I don't know. So everything is like a black box. Is that right? Everything is like a black box. So what inference I need to get from the data? I need something out of it. So when I need something out of it, it should be a true signal. So whether it is a stochastic, a random, or any inherent signal. So that is very, very important, especially in signal processing. Everybody talks about signals. Okay, sir, signal has, I have a signal, I did the interpretation, I did a configuration, I did the analysis. So when I do say all these things, how I am going to do interpretation for understanding? Is that clear? So how do I interpret the data? Interpretation is very, very critical. When I talk about interpretation, I need to sequentially understand the segments. When I need to understand the segments, I need to put them as a loop. So when I need to put all this data in a loop, how I am going to balance this for a acquisition? So just like that, control and optimization will not come directly for a human machine interface. All these are subparts. I need a measurement, I need a model, I need a evaluation. See, everybody nowadays talk about AI and other things. AI cannot validate the model. If we are not doing a validation with the model, it will show something. Instead of human being, it will also give the answer. Like chat GPT, you type anything, there will be answer. But how do you validate? How do you see? Say, for example, I want to apply a for healthcare systems. I need to mathematically understand the human body. As I said, the entire human body is having 64 differential equations. My brain, gut, liver, kidney, to my toe, everything. See, whatever the exoskeletons we do talk about are all linear models. So when what is inside the human body becomes non-linear. Why? Because the exoskeletal model, either you move this side or this side. Am I right? Your posture is fixed in your, maybe in your finger. You see that you can do a movement like this. You cannot do a movement like this. Okay, all are fixed linear motions. Fixed linear. I can move my finger like this. Okay, so all the movements are linear movements. So my control philosophy is very easy for these things. When I have non-linear exhibits, my control law is totally going to change. So non-linear exhibits like kidney, if there is a dialysis patient, suddenly if the dialysis is going to give a reverse flow, what would be the effect? So such is the case of heuristics happening. So only we do talk about meta heuristics. So many models are available. Those models also used for geographical understanding of the system. Okay. So what would be the outline? Yesterday we had a very brief introduction to HMI, and with respect to HMI, we need to talk about more on automation control system and control and optimization methods in HMI, human in loop optimization, challenges and future direction. Batteries, no? Check the battery. Next slide. So you see that yesterday we have talked about human machine interface, but you see, okay. So what is an HMI? So yesterday we have seen that how HMI is going to integrate the rehabilitation process as a part of the GYAN course. What is the rehabilitation programs we available? And you see that it is a critical environment to understand the system in a loop. See, before 15 years, you see that the CCTV camera was not at all accepted. Okay, even police people does not like. But nowadays, they themselves insist that CCTV camera is a must. It's a child display camera. Now, so many cameras are available to see the posture. I'll be talking about gait posture, especially since physiotherapists are also here. Many of the criminal systems, crime occurrence are done through some different methods. Especially, you see, crime is done by closing the face. The crime is done by closing the helmet. So when he closes everything, how do you see the posture of the person? That is a next important problem for crime. So when there is a crime, police people, next important thing is their gait posture. They will understand the posture of the gait. So movement of the track, movement of the person, because he cannot close everything. He can close his face, he can close his finger, but he cannot close the walking posture. So when he is walking, he will see the motion of the walk, and that's how many of the crime detection studies are done for using gait systems. So I'll be talking about in my last slide on how these things are done. So everything has a intuitive through screens and input device. I need the information. See, nowadays smartphones are popular. So only many people are not bothered about the HMI. Okay, so you are connected with your phone. If you have your mobile phone, you can see your camera is on or off in my house. Okay, is that right? So all the HMIs are popular enough to get the inputs and send the output. So for getting input and sending output, the basic measurement is not strong. Everything is gone. See, everybody, even virtual reality or augmented reality, anything, if your basic understanding in validating the system is wrong, everything will become wrong. So for this, the core components of HMI are display screens, inputs, and programmable software. So now many of the open source softwares are come in play. You see that even in our computer support group, we use smart softwares where all are open source and all are configured for system study. So how does it evolve in 1950s was through punch cards, and you see command lines, revolution, graphic user interface, now touch and mobile. So this is the state of art. You see that this is the state of art. Especially every mobile phone has a HMI. Okay, every mobile phone has a HMI. So when we talk about this, the first popular origin of this was automation. So now the same robotic surgeries are done in many hospitals. Okay, so the same robotic surgeries are done in many hospitals. So HMI is not only for industrial automation, now it is also for revolutionizing the system study. The revolutionizing the system study. So when we talk about how it is going to revolution, you see that many of the robotics have their own arm, how it is going to do a surgery based on the instruction of a doctor. So it has to do an instruction based on the, or else it is trained by itself, it will do something else. So when we talk about this, we call this as automated control system. You see that the productivity is increased. See, if a neurologist, you could see that nephrologist or neurologist or cardiologist, you see they will fix the procedures. You can see that in a day they have to conduct 5 different surgeries. See, you see, they are also human being. At one point, they will feel vexed in doing the same repetitive task. Whereas in machine, you could program it, but you should also have a monitoring system. If you are not monitoring that, that will also have problem because of the quality and manual interaction. See, even if I am giving a manual instruction, it is okay. If it is not so, if it is not obeying the law, everything will have some deviation. So this is part of the industrial control system, where nowadays even we use SCADA, PLC, and DCS. These were also popularly used, and now many of the devices, when we talk about automation, these devices are in place, especially in CT, MRI. Many of the machines have these industrial control systems. So when we talk about these things, there will be integration of these two things, like what PC is going to do when I connect my mobile to a PC. So I can now connect my mobile through a Bluetooth. There are different modes of connection. I can connect it through my USB port or Bluetooth. Nowadays no more RS-232 and parallel ports are available. I can use a bus communication protocol to connect all this. So it has different terminals. You see, this is the importance of understanding these things in a remote communication. So when we have remote, see, when telemedicine was in place, when telemedicine, how it has been started, before 20 years, you see that ISRO will bring a very huge bus. That is how telemedicine was started. They will park in front of NIT, popular hospitals like Aravind Eye Hospital, because all the patients are sitting in village. They cannot make the patients to come to the city. So these telemetry system visited many of the hospitals. They cap many of the villages. The patients are subjected inside the room. They capture, send the through satellite communication. That's how the access was established. Okay, but now you see that all are through communication protocols, but all are through wireless communication protocols. When the protocols talk by itself, it receives the image as early as possible. See, why there is so many of launch of space vehicles? You should understand why ISRO is sending so many space vehicles. Three important things. One is for irrigation, one is for agriculture, one is for healthcare, and another is for fishermen. Three important things are for these things. They need a better communication radar. See, you see that there is a cross border. The fishermen will not obey their structure. They will, wherever their objective is, wherever the fish is there, they will go. They will not see the line of control. Okay. So when they moving out of the control, immediately you see that there will be a firing from the opponent. So such modalities are controlled, where controlled. See, many of the digital systems are there, but you see that automation helps in understanding these things through a remote terminal unit. RTUs are in place. Even your mobile has a inbuilt transmitter and receiver. So it has a inbuilt transmitter. See, why we call all this as a smart device? Better, everybody should know why. Whatever, sir, I have a smartphone. What is smart? Anyone? See, I have a smartphone means what? What is smart? What is smart inside the phone? Anyone? We call everything as a smart device. Am I right? Why it is called as a smart device? Huh? In another form, input to in another one form and output. So we call this as it has inbuilt transmitter and receiver. Is that clear? So I can transmit, I can also receive. It has an inbuilt transmitter and receiver. So this is a very, very important acronym in many of the communication systems. See, this is the communication system where HMI is very closely connected with many of the medical devices. So you see that the scenario is nowadays everybody uses a very important understanding that சொல்லுங்க வந்துடுறீங்களா இன்னைக்கு 3 மணிக்கு இல்லை இல்லை அவர் கிளாஸ் எடுத்துட்டு அப்புறம் okay. So you see that the basic fundamental was started with data acquisition system. Why data acquisition system? Sir, whether my system will have suppression of noise. Whether the suppression of noise is through data acquisition system. But nowadays, whether everybody is using lab, you know. Am I right? Initially, it was a plug and play device. So we used LabVIEW to plug and play. But nowadays, everybody uses LoRa, many Python programming, many of the user ASIC processor, many embedded tools are there. So they use application specific hardware. Is that right? Application specific hardware. So this is the basic understanding of any physical sensory signal conditioning system to capture the dynamics. So as I said, when there is a noise, I should design a filter. When there is a filter, next is how do you capture the system, whether the system is a linear system or a non-linear system. When there is a linear or non-linear, whether your control law is going to be for a linear system or a non. So all these things are very, very important for understanding. So when I do talk about this, you see that the signal conditioning system is going to happen like this. So when we have all these things, you see, I have to do a monitoring. See, every control panel, every data center will have a data storage room. See, even if you see our supercomputer is like that, even you can see our data center in the first building, all are having inbuilt server. If you see that it has this is a control panel, not only it captures the data, it also stores. So it is well protected with a firewall. Everybody talks about the data security, cyber security is there. I need to protect. So like that, each and every hospital nowadays they have hospital information system. Everybody has hospital information system, because the first and foremost information is that doctors will not share the digital data to the patient. Okay, all the digital histories are well protected. Why? Because if there is a ethical law in our country, that it should be prevented with, it should be shared with the concern of a ethical clearance. If that's ethical clearance is not shared, you cannot have your data as a public. So every hospital will have their own hospital information system. They will store the data. They will give only summary, discharge summary report. Why? Because their interpretation of doctor is also seen. Nowadays, you see, many of the discharge summaries are also written by many of the doctors using ChatGPT. Many of the doctors, okay. This was a very important history from one of my friend. He also said, sir, it gives a discharge because I need a technician, I need a trainer, everybody I have to build. If it is a ChatGPT, I myself will post and I can get the discharge summary in a minute. Why? Because discharge summary gives the reflection of the diagnostics. So such is the place. How do I trigger the data? How do I get the data? Tap the data is very important. So for this, these kind of systems are well placed. So how do we integrate all these things with PLC systems? So nowadays we have these integrations. How do all these things are done as schedule? I need to do a scheduling. So when there is a scheduling, you see that you have a sensor data, you have a HMI, you have a PLC process update, and you also have operator commands. So all these commands are going to instruct each and every user how to take the things forward, how to take this for the health industry, how these things are going to be useful for the updates using HMI. So any update, whatever I do clinically, say for example in ICU, whatever the data is displayed, whether all the data will be shared to a doctor, yes, it has to have a remote access, because the doctor will see from the mobile phone what kind of inference and advise the staff accordingly. Treatment planning system will be done accordingly. So these are all the key functions. First and foremost is monitoring, control, alarm management, and data logging. So alarm management is where you see in ICU. If there is any abnormality, any human, see any staff nurse, you see 24 hours, 24 hours, such critical patients are there. Okay. When there is a critical patient, especially in the midnight of 1 or 2, if the patient is in proper condition, okay, if they are in coma, they will move their hands, legs anywhere. At that time, if any parameter is gone beyond any limit, you see an alarm management. Alarm management is going to be one of the very important parameters of HMI to integrate for rehabilitation programs. See, many, if say for a patient, he does not able to speak, he does not able to move. So all these movements are seen only through a camera, and if they want to do anything, they will give an alarm so that immediate attention is required. So alarm management is very important, and at last data logging. So these four parameters are very, very important in integration of HMI over rehabilitation engineering. So when we have these things, what is the four important tasks we achieve? One is enhance the visibility, improve the efficiency. Next is for a safer reach. A patient is for a safer reach. See, even though the patient is under coma stage, in the recovery of the patient itself, the hospital need to take care of their primary safety and cost. See, at last is the cost. If everything goes well, everybody asks for the cost, and that is affordable, and many of the government hospitals have such facility. So when these things are happening, now everybody talks about, see, before that, before everything, we had PLC, SCADA, all this data acquisition system, but now everybody talks about mobile and web, whether it is a web enabled system. Even I think since we have physiotherapist Suresh and madam is there, many of them ask sir, is there any social things without information, so that any mobile web access can be done or not. Am I right? So they will be, they are in a process, because today I will be in Trichy, tomorrow I will be in some other place. So at that time, but their expertise is well validated for these things. Next is high performance focus. High performance is faster rate, faster. So only you see that WhatsApp is becoming so popular. Why? Because it's very faster to address. If you call itself, if you call or if you give a message, it takes some time. In a WhatsApp, you can reach in. So only you see wireless phones are avoided in many of the hospitals nowadays. Mobile is with every feature. The third important thing is IoT and AI integration. So you know Internet of Things. You see the accessibility of IoT and how these IoTs are going to influence. All are through IEC protocol. Please understand that as far as international standards, we need to talk about IEC. As far as Indian standards, there is a BIS, Bureau of Indian Standards, which talks about these integrations. See, unless these integrations are not with standard, I cannot go for extension. See, the major problem in HMI in rehabilitation is that I need to have a OPC in the sense object linking and embedding for the control application. So I need to enter, because my PC has a bus communication. This is a universal standard. Nowadays, you see, after becoming USB, you can bring any item, import substitute from abroad. You can plug it as a USB. Before and all, it was very difficult because their pin configuration was different. We cannot do anything as we think. Is that clear? So first and foremost, for any device, the integration, that is communication, is very, very important. The third important thing is very, very important. So what would be the future, you know very well, now augmented virtual uh, driverless vehicle. So already you see that many driverless vehicles are in place, and you see this is how the future is going to be without any human intervention. It will have automation. So you see a hall without any human intervention. It is by itself, as I said, it is by itself. It will replace human for everything. So you see that it is an intelligent leveraging systems with augmented and virtual reality. Any intelligence, whatever you speak, it works based on the automation, and as you think, these things will be for the user. So now you see, when automation is in place, you can also talk about the control part, how these things are integrated. See, if there is any false alarm, we cannot completely negate if there is any false alarm. Say, for example, everything is under automatic mode. See, when a surgery is posted on robotic surgery, when a robotic surgery is posted, the doctor will fix everything in a automatic mode. It cannot be a manual mode. So when the surgery is going on well, okay, if there is any problem, he has to stop. He has to stop the surgery from that is called as a redundant system, fail-safe operation, especially fail-safe operation. He has to stop. He has to switch over from automatic to manual mode, do the correction, and again get back to the routine. So such kind of, so only, even though you see all these things are there, HMI only gives us a clear picture of understanding the objects of system study. So why control and optimization is mattering a lot? It is complexity. As I said, complex systems are in place. Human body system itself is a complex. See, now even a ventilator, a dialysis, a defibrillator, you see a panel. Every panel has HMI. All the panels will give the inbuilt parameter, pulse rate, oxygen, what is the level of everything is displayed, and accordingly alarms are generated. So when alarms are generated in proper sequence, you see that these kind of challenges will be established. So now human in loop optimizer, I think that's where Professor Ramana is working on many of the robotic optimization, where you see that this is going to be the feature because of the adaptive intelligence. See, before and all, you know very well that uh, especially in landing of airspace vehicle. Okay, so Trichy is a very small airport, but this is not the case with John F. Kennedy Airport in New York. Okay, you can see that here rarely around in a day we will have around 10 flights. Okay, whereas there in a minute there will be hundreds of flights coming from different routine. So how does this loop optimizer work? So it does a scheduling. It prioritizes various events, and accordingly it gives credit, because some flights may say it is an emergency because that priority has to be fixed. Sir, my fueling in my system is very less, so allow me first. So such is the case. Whether that fellow is saying truth or not is also bothers. So they will measure everything, and then only a call has been taken. So such kind of optimization is in place in many of the space vehicles, and it is also there in driverless vehicles. Okay, so when driverless vehicles are there in many of the roads, where it also decides the lane path, accordingly it moves from one lane to another. So such kind of decision making, so only it is called as adaptive intelligence in case of understanding the biological behavior of any system. So based on this, now everybody talks about MPC means human context. So many of the model predictive law has predictions here. So why? Because see, when we go to a doctor do talks about history. So this prediction is like that. What it does is that, like when we are driving a car, I should see on front, I should also see the right hand mirror and the rear mirror. So all these things only will give a predictive understanding of the planning. I should forecast what is in my front. I should also see what is in my back, what is on my right, what is on my left. So all these configurations are very well understood, and based on that, you see the best example is the table. They have tab, based on that they will move either to the left or right, and accordingly the patients are moved for either it is a CT or MRI integration. So based on this AI enhanced support system, especially you see that HMI with many of the control, see you see these things in many of the school exhibitions. Many kids do a project, especially you see a fellow that kid may be a 5th standard or 4th standard. He talks about temperature, humidity, all the sensor, all the parameters are logically measured using the mobile phone. Okay, when such is the case, it is not through wired but everything through Bluetooth or Python or many integration tools are available. They will display these results accordingly. When such is the case, when the display is for different segments. So ergonomics used for these kind of centered industrial automation is there are so many ergonomics are used. Ergonomics in the sense how the posture. See, say for example, any protocol. When I define any protocol for subject, see any protocol for EEG or EMG, any measurement, I need to configure using the centered ergonomics, where without the dynamics of the system, you cannot change the system just like that. Okay, you cannot. It will not understand. It will not understand, and it will give a erroneous outcome. So these ergonomics are also very important to meet the cognitive balance and AR introduction. So all this cognitive balance has been well established for these kind of integration. And what is the importance of these things? One is the planning, and one is to understand the tool, and another is to implement the system. So based on these optimizing structure, these are all the examples which have been taken for the path planning in robotics. So robotics comes into existence, especially in many of the industrial platform for these things. When such is the case, you see that the planning is done through a model predictive controller. See, the law clearly states, the law is like the MPC structure itself is like an astrologer. So what does the astrologer do? He takes from your word of what is your name, of what is the current, what is the past, and he will say based on the current and past, what is the future. So your MPC is like an astrologer. So what are all the history he will take, and it will be given to an optimizer, which is nothing but J is equal to summation of maximum minus minimum the whole square. So that optimizing law will helps us in minimizing the function. That minimization will help in understanding the best tool for these kind of diagnostics. So these are all the visual impacts of the structure, and what would be this structure with respect to the measured outputs. And you see that the measurable outcomes are very well seen in case of the reduced errors. So what are all the challenges, especially for this, the future direction? See, the importance of this is many of the systems are industrial driven. Many of the systems are industrial driven, and many home automation systems are also in place. Okay, many of the automation systems, especially in medical clinical side, is also in place. Whether it gives a logical structure, yes, that is the very important logical understanding we should evaluate, and it should be, as I said, modeling, control, and optimization. Based on this, the convergence is achieved with respect to the feedback of the system. So any surgery or any clinical evaluation is based on the history of understanding. So based on this, these are all the important takeaway. One is we need to have established partners with human-centered approach. So the thing is that technology will be there. See, even in Trichy, you have many renowned hospitals doing robotic surgery. What is GVN hospital has come out with many robotic surgery, but how far it is logical, especially for giving a chemotherapy for patients who are under a tumor. Your treatment planning system should be correct. It should be perfect. If your treatment planning system fails, the chemo itself will result in confusion. It will instead of the radiation effect, it will be a diversion effect such a way that it will propagate inside the body. That radiation will illuminate. That is how many of the failures were happening in cancer related study, because there was no smarter control tools. But nowadays all the devices have very smarter generation, so that if you want to give out the radiation of the very specific part, these tools will help us to identify where these structures are. They also have wearable devices. It will understand better. It will understand better. It will not allow for any propagation. If there is propagation, it will alarm, so that these kind of preventions are also taken away. So based on this, uh, uh, we could see that Mallikarjun, last night we have had it now, yesterday night. Huh? No, that measurements. So okay, so this would be the part of introduction, and we'll also be talking about the measurement part. So do you have any questions till to what I've handled? If you have any questions, you can always ask. Yes. Everybody is asked to follow a lane. Okay, whether everybody is following that. No. See, my question is, there are so many, only one way. You come from Trichy to Tiruvallur, you should not do a wrong entry path. Okay. So you see, when you are coming from Trichy to here, how many of them going in the opposite direction? Whether we are obeying, because our ultimate aim is to reach. Like that fisherman, see where the availability of fish. Okay. So accordingly, they will go. They will think that, see, if there is a violation, maximum they will shoot. Okay. At that time, we will try to escape. So if we get hold of so much of fish, I can make money. That is intuition. Slowly, many lives are lost. Yeah, LOC. See, you can see how the aerial drone. How do you fix the geographical position? Huh? So how do you fix the map? Geographical map is fixed. Accordingly, the drone is fluid. Am I right? It will not deviate from the original path. So like that, everybody is doing, but nothing is optimized. See, we are saying that you should not, you should keep your cattle, goat inside your house. But many people letting them to for straying in the highway. You see, many accidents are because of that. Hmm? What is the next slide? Okay, so as a part of the first presentation, I'll be also interested to talk more about actuation. So already they would have talked about exoskeletal model and other related things with respect to EEG and EFG. You see that how a control logic is between the sensing and actuation. So how does the control and actuation is done? And you see that why an actuation? What is the need for actuator? Yes. Huh? To perform the task. Yesterday itself I said, no example, see any implants or any prosthetics. If you are doing okay, sir, if when in opposite we have so many industries, especially machineries, they will cut their finger. Okay, okay, we will replace it. Whether the finger is, everybody will appreciate to be like this? No, I need to do actuation. See, Jaipur foot was initially well appreciated, but after that, when it comes to actuation, we cannot do. Is that clear? So now everybody is smarter enough to, even though if you give an assistive device, they want to perform like what is actual. Okay, many assistive device in India is becoming failure. Why? Because it is not on par with the regular system. So they want everything to be with the regular system. So you see that here I will be talking more about assistive technology, therapeutics and neural and sensory system. You see that it has smart wheelchairs, prosthetic. Yesterday itself we talked about these things and how many of them are involved in development of smart devices here. How many of them? See, I could see many biomedical engineers, but how many? Yes, anybody? Anybody work on developments, especially with respect to smart systems like assistive devices? Huh? Huh? Oh, you are from which? Oh, Anna University. So, see, it's very good that from Anna University, Madam Punglali, she is also they have developed a very good smart wheelchair, and it has been well connected with the EEG system. Okay, it has been well connected. Why? Because see nowadays designing wheelchair is not important. How it works based on the intuition of human being. See, if that vehicle is very good, I can also make the vehicle to take it inside my car. Okay, recliner systems are available. You see, many recliner systems are designed to facilitate the dynamics of the human body. So, a patient is different, a comfort is different. Everybody needs comfort. Patient is different and comfort is different. So, such kind of comfort is seen, for which many mode of operandis in Coimbatore is working on it to escalate. See, like a ramp in a vehicle, I can make the wheelchair to automatically get inside the car. It's a comfort. So I am providing a comfort such a way that the patient need not walk. Okay. So everybody starts developing such things, such recliner system to give comfort. And here now in neural engineering, everybody talks about brain-computer interface. Yes, brain-computer interface is also complex task. See, why do we develop models? And as I said, why do we validate these model? Is it should understand. It should understand the neuronal thinking of any behavior. So only you see that many tools are coming into picture to study the data, feed the data based on that how the patient is going to behave. So when it comes to the HMI in rehabilitation, you see that it has to have a detection as well as optimization. So optimization is a very interesting. See, there are so many optimization law is available. You have to select the best optimizer, so that best and easiest optimizer. There are, see, Newton-Raphson method is one of the basic optimizer. You see the convergence, how our convergence is reached at a faster rate. So like that, many complex algorithms are there, but you should make it as convenient as optimization systems are. So here, this is the very important law. You see any controller, actuator and plant systems with sensor. Now everybody, every physical or physiological control system is very much dependent. See, before and all it was a feed forward system. Now you could see a feed forward with feedback system. So these are all the basic multi-objective functions. You see that the law is linear to till this position, and you see a non-linearity here, and again you could see a linear zone. So such kind of complexity may arise in the human body. When it comes to the complex understanding, you should see that uh, these kind of captures are very important for logical understanding, and these captures will fine tune according to the growth of the optimizing system. So based on this, how do we integrate? You see a model, design, deploy, and adapt. So adaptive systems, adaptive intelligence are in place in many of the system design. System theories are having adaptive strategies for many of the control loop. So based on the adaptiveness, you see that the challenges with different problems are originated. I have to configure these problems based on the path, and according to the path, these locations are identified with respect to physical connect. You see that cognitive understanding is also making the thinking. That is, cognitive understanding is you have to make your sensory system so fast for making this as an adaptive one. So you see there are various control laws which are, it starts from PID. Basic PID controller is start. but now you see that anything is with model and without model. So how fast I am going to develop these control theory foundations, especially with respect to time domain, with respect to frequency domain, frequency plot, with respect to different observer design, with respect to adaptive systems. And nowadays, many systems are non-linear. We cannot, especially adaptive optics is going to play a very important role, because you see so many inherent parameters are affecting the vision of the eye. So if it is a cataract, okay, you do experiment, you do. If it is a syndrome, you may lose the vision. So how does that rehabilitation is? See, rehabilitation in different streams are available. As I said, in clinical side, we cannot talk about only with exoskeletal and other related thing as a rehabilitation. Even the vision is very serious. See, many people, if you are really diagnosing, if you are not detecting, it leads to blindness. Okay, so all these things are very, very important. So such parameters are coherently linked, and you see that the architecture itself is like this. You see the human operator, high level, medium level, and actuators and robotics. See, many of the activations are done in robotics based on the control law. So how do I integrate? See, so only when we design any system, first and foremost, designer will ask what is the degree of freedom. How much degree of freedom I am going to use? What is the input and output? See, anything, so only any clinical surgery, before performing everything, they ask history. History about what was the past, what was the current, what is the any history, whether the patient has cancer earlier. All these histories are because of these kind of the hierarchy which they develop, especially for robotics. And these are all the basic things. Whenever the open loop systems and closed loop systems are in place, now everything is in closed loop. We have to control the structure, and this is how you see that the humanoid is very much seen with a basic error signal. So you see that how a error signal is going to actuate. See, by seeing the vision itself, I can say how much is the error. It has different orientation. See, parallax error is one such example. It has different orientation when I see it forward, when I see it back. So you see these kind of the system study will have different estimation. One is state estimation and online controller and forward models and inverse models, so that these scenario will be with respect to the structure of the feedback system. So any feedback system will be through this, so that it gives a exorbitant perturbation to see the outcome of the prosthetic environment. So you also see that robustness is also seen, which is nothing but uncertainty. See how far the patient is certain, especially in autism. Autism, you see that a patient has to listen to the law. If it is trying to deviate, the uncertainty comes into picture. So it will be a robust model, so that accordingly your law is retuned, and according to the law, you see a very important outcome. You see that the performance on the robustness is very much seen. There are so many papers on this robustness issues, because these are all some of the frequency domain problems which encounters nonlinear address. So these are all the examples of other damping systems, especially in virtual reality. And as I said, the stability on the Liouville understanding, stability, I need to understand how far the patient is stable, because that is very important for understanding the model of any evaluation, and that would give the outcome, especially with respect to robots. And you see how a passive and passive is a stable structure. So controller design methodologies have different studies, but everybody prefers to have pilots, and you see very well the pilot study only implements the recursiveness of the patient, and it takes the study in a better way. So there are several performance metrics. At last, I need to talk about performance metrics. Performance metrics will understand the stability and control law for different orientation. So based on this, you could see that the control strategy is evolved based on the different loop, which is nothing but the redundant system. So I need to have a redundant structure. Redundant structure in the sense, when this system is working better than this, I need to replace, I need to do a switchover for these kind of studies. So based on these, I have already talked about the optimization problem. We can see that any optimizer has a j of x. That is, j minimizes the function law, and you see that how j inside the x is going to influence the parameters with respect to different schematic understanding. So based on this, you could see that how the objective function j is having a composite understanding with respect to adaptive weighing strategy, and you can see how the weighing structure is also seen with respect to the optimizing front. And you see that there are different constraints. It is an inherent constraint. Constraints in the sense it is of a bounded input and bounded output. You see that how the constraints are placed inside the structure with respect to the function to operate these things in a safer zone. Based on this, there are different programming methods, linear, quadratic. These are all many of the stature in recent control law. And you know very well, the nonlinear optimizer is used through a non-convex optimization. These kind of bulging effects are very well seen, especially spiking effects are very well seen in an optimization path with respect to the different stages of the control scenario. So genetics is one such effect. I think many of them have studied in your course. And the particle swarm optimization, how the particle reaches the swarm, so how it fetches the prey. So this is a very interesting law, and accordingly these laws are applied in different schemes for different applications, especially in healthcare industry. And multi-objective optimization is another optimizer. You could see that when minimization is done, how the law will converge to a particular point. So that kind of multi-objective optimizations are also seen in many of the critical system design. And this is where, as I said, many of the robotic applications nowadays are human in loop, HAL. We call this human in loop in optimization because I have done so many things, but I want to test it to a patient. Before testing the system to a patient, I can use hardware in loop, where this optimizer will get the data, test it, and send the data back. So HLL loops are very much prominent in many of the medical industry. So based on this, you could see that the efficiency of these criterions are very well established in different capture of dynamics, and all these captures will result in the measured outcome. And based on this, you could see that the reinforcement RIL, we also say that RIL is in many of the genetics study. Reinforcement learning will also helps us in better understanding. And based on that, you could also see a gradient-based learning is seen. Gradient-based learnings are also applied for based on the different personalized gate structures. And with respect to BCA, I think already they would have talked about BCA, EEG, stroke rehabilitation. So prosthetic control system, and this is whatever I discussed, especially on prosthetics. Nowadays, sports and medicines are very connected, especially in prosthetics. You see that. So this is the myoelectric control principle. You see how myoelectric potential is created, and based on that, control unit is triggered. So different control law, different control schemes are applied at different heads. So pattern recognition with respect to feature, a proportional control and pattern recognition system. And you see that intent detection algorithms are there. Based on that, you could see that control allocation structures are monitored, and sensory feedback system. So nowadays, everybody design such prototypes for many of the understanding. And this is the study of the adaptive prosthetic control. You could see that the study is very much clear on many of the parameter isolation, and the clinical evaluations. And you see this exoskeletal and robotic system. I think Karthik and Professor Ramana would have built all these things. So it is a summary to state all these things comes under this particular umbrella. So this is very, very important because many of the practical examples are done through uh, self-tuning regulators. Self-tuning regulators and adaptive regulators means what? So I said I talked about a PID law, okay, PID control law, which says that the parameters are selected. Okay, the parameters are selected means by means of what? I need to have certain parameters, say maybe alpha and beta. So if any tuning parameter with respect to alpha and beta, this self-tuning regulator is nothing but it will adapt itself and orient itself to a specific task. Okay, so when it orient to a specific task, how does it is going to display? So the orientation is done through a self-tuning regulator with measure, synthesize, and the structure is through a tuning parameter. So based on this, you could see that the wheelchair control system, I think they have already discussed. So this is I think gate systems also they have discussed about as a gate. So you see that different stages of gate and the walking posture, whatever I have explained, through different symmetry. And based on that, you could see that the clinical tests are done. So what is going to be the future, especially on the device development? So all this are for assistive device. So you have to think by and large because many of the control optimization problems, many of the students are not working. So only I want to show all the slides. Why? Because it is opening for many of the students that physiological control system is going to be the future. Physiological control system is going to be the future, and the future is not only on dependent with the tools, it is also dependent on hardware. So how much you make the device to configure. Is that right? When a device is configured and made a user as simple as what they are, then you feel that the prototypes are successful for many of the implementation. So uh, this is the standard benchmarking. Please try to follow the standards. Ethics, accessibility, and equity is very, very important in HMI. As I said, integration is possible, but ethics, accessibility, and equity stands everybody to have a better understanding for future. Is that clear? So, do you have any doubts? Any questions? So, ready? So, what is next, Archana? Feedback form afternoon only. Your feedback means the event is closed. Huh? Huh? You what, Ramana? He will come. He'll come. So he has gone out for a meeting. So he'll come. Maybe after tea, he'll be starting his session. Okay, tea is tea. Okay, so we'll. If you have any questions, you can ask, and please see. By and large, all are in this domain. Why? See, yesterday also our coordinator asked, Gyan coordinator, sir, for your course you see numbers, but in many of the other Gyan course we don't have numbers. See, the numbers is the good response, but we also want many students to develop on the prototypes, and you can always interact with us so that you are the future for our country. So only many of the students you can see, you can meet Professor Ramana everywhere. Ramana and his team, they are very much helpful to give very good masters. If you are interested, keen on masters programming or PhD programming, please try to have intention. Please go abroad, try to get all the details, come back to India and develop a very good system to cater the requirements of poor and needy. That itself will be a challenge for this kind of workshop. So only we are making many people, and you know very well, bringing their time from away from US, staying here one week is totally different, and you see that both technology as well as balance. Unless we give back, see, getting is always one thing. You should give back to the society. That give back is very important. Please understand the seriousness. Work for prototypes, work for models, work for innovation, and see, it does not come in a day. It will be done based on your thinking. Is that right? Is that right? So I hope everybody had comfortable stay. Every participants, in spite of your busy schedule, you are also here. Please always interact with NIT, and you have scholars from IIT Madras, you have scientists from other institutes. This is a very good platform for you to meet, get their info. I have a very good group to develop some system. See, unless you have a group, self-sustenance will not come up in biomedical. So now everything is IT enabled solution. Please take away, don't study everything. Whatever your expertise, your friend is on different domain, try to have everything understandable. Then you can think for future for our country. Thank you. Please join for